Okay, we've been talking about factors, exponents, order of operations, and various other basic math operations. Now we'll be talking about the final one, roots. The root of the number is the number you would multiply by itself to find the number whose root is being taken. The square root of a number is the number squared. That gives you the number whose square root is being taken. So you look at the top right, that is the symbol for the square or the root of a number. If it's not denoted as to what degree the root is, it's assumed it's the square root. Okay, so the square root of 4 is 2, since 2 squared is 4. You see over on the bottom right, I have square root of 4. That is how we would write it out. If they said, write out the square root of 4, that is how you would illustrate it mathematically. And like we said previously, since the number squared is equal to that number, 2 squared is equal to 4. So the square root of 4 is 2. The cubed root of 8, and we see the notation over to the right of it, the cubed root, you see the little 3 in the crook of the root symbol. Cubed root of 8 is 2. Since 2 multiplied by itself 3 times is 8. 2 cubed is 8. So the cubed root of 8 is 2. We're going to do a problem concerning roots. Whalen, a rocket scientist, needs to estimate the speed a rocket is traveling in kilometers per hour during descent. The speed varies according to atmospheric conditions. The formula for determining the speed is S equals the square root of 50 ZD, where D is the distance in meters and Z is the coefficient from the chart below. You see I have the Z value, 1 engine, 2 engine, 3 engine, clouded, unobscured. So we have that formula, S equals the square root of 50 ZD. If the 3-engine rocket traveled a distance of 30 meters in a clouded setting, what was the speed in kilometers per hour? Okay, I'm going to need you to figure out the problem on your own. Remember, as always, you can press the space bar to pause the video. I'll give you a moment to do so right now. Okay, we're back. So let's work through the problem. Now, we're going to take the root of, we have 50 already. 50 is a constant. Z, what is Z? Z is the Z value from the chart. How do I get that? It's in a clouded setting. There's 3 values in the clouded setting, 77, 89, and 100. It says it's a 3-engine rocket, so that's not 1 engine clouded, that's not 2 engine clouded, that's 3 engine clouded, which is 100. So I plug in the 100. And the distance traveled is 30 meters. So I'm going to plug in the 30 for the D value. So root of 50 times 100, the Z value, times 30, the D value. I take the square root of 150,000. You can use your calculator. That's what I did. The square root of 150,000 is 387.29 kilometers per hour. Again, be very mindful of the units. Sometimes they trick you. Also be mindful of the fact they gave you a lot of material that was irrelevant to solving the problem. I didn't have to know about rockets. I didn't have to know about what Whalen did in his spare time, that he was a rocket scientist. I didn't even have to know about the descent, which in a line graph problem might be important because the descent of a rocket would indicate a downward trajectory. The line would be pointing down. On descent, on ascent, it would be going up, but on descent, it would be going down. A rocket would be going down. Okay, so let's look back quickly, just so I can reinforce that a lot of times the GED will put irrelevant information in this word problem. So a rocket scientist needs to estimate, doesn't matter that he's a rocket scientist. So we need to estimate the speed of a rocket in kilometers per hour during descent. The speed varies according to atmospheric conditions. Okay, so we have a formula, square root of 50 ZD. D is the distance in meters and Z is the coefficient from the chart below. So all we need to know is, okay, what's the Z value, what's the D value? And we have our D value is 30. Our Z value, we look at that chart, 3-engine rocket. So I just look at the chart, it's a 3-engine rocket, 100. Okay, that's it. And we'll pick this up next time in the next lesson, which will be on a new topic, lines. I'll see you there.